Sorry, thank you. Please find Victoria during the break. Let's welcome our next speaker is Charles Lin from National Cheng University. Is this online or? Oh, sorry.
Oh, sorry. Hi, this is Cheng on behalf of my colleague Charles Lin. Today I'm going to report our products that the global ionospheric specification and the related research about the solar variations. Okay, so why we need the 3D ionosphere? Because the G-base airport, they are using the aviation utilize the single frequency differences to remove the ionospheric delays. But we both know that the ionosphere delay is highly dependent to the gradient in the ionosphere. So to find the three-dimensional different gradient of the ionosphere is crucial. And unfortunately, Taiwan is located at the most intense gradient region, that the north slope of the EIA in the world. So that's the motivations that we initiate this research. And this is some basic information about our models, a simulation model that we use a combination of the radio occultation data and the ground-based GPS tech. And those real-time GPS tech will have the 1 hour latency. So far we have our capabilities using the 10 to 15 minutes to output 1 hour data. So that's the limitations of the new real-time observation so far. And our coverage is within the 100 to 1,000 kilometer in altitude. And there are two types of the output. One is in the 5 degrees longitude, and the other one is the 2.5 degrees in longitude. And both for the altitude, they have more precise in the altitude resolution. So those for both products that we have the two distinct temporal resolutions here. And here is the one example that the data we use in 3 hours that we use for establish one GIS product. And because of there's a more denser data distribution in the low latitudes that within 3 hours. So comparing to the COSMIC, then we have more precise, more detailed structure of the ionosphere that we can show to the product. And by this kind of products, then we can also observe some short-term short-term phenomena in the ionosphere, such as the quasi-6-day waves. And we found that during the 2019, the stratosphere warming, that there's a very collocated, very intense quasi-6-day waves during the day. And our product can also observe a kind of structures here. Yeah, and so this is just one example that we can use for that. And also, during the 2019, there's a very minor geomagnetic storm. The DST only goes to the -50. So comparing to the Halloween storm DST goes down to the 400. So during the very minor geomagnetic storm, we can, by GIS, we can also find very intense response of the global density increasing. So this is the reference day, that 1 day prior the storm, and this is the storm day. And if we take a difference of the two columns in the left-hand side, then we can find that the EIA chart, and so EIA lobe, northern lobe, goes to the higher altitude, goes to polar distribution. So this is very similar to the Halloween storm in the solar maximum. But during the day, that was the solar minimum in the year 2019. So we are very surprised that they share very similar results and similar density increases in both EIA peak. And also by using the GIS results, then we can also find that the increasing of the both peaks and the peaks goes to polar altitudes. And another examples that we can share is that there's another geomagnetic storm at May 2024. And these 3 columns also shows the prior 1 day and observation and the difference. And this time I would like to introduce you to the features at the Northern America here. If we enlarge the figure, and this is the reference day, sorry, this is reference day, and this is event day, and this is the difference. Then we can find the plume and or the we call the density increasing at the northern hemisphere, and it is very similar locations and patterns and even times occur that observed by the ground-based GNSS before and also for by the radar. Also, because this kind of a global distribution of the observation, we can use it to observe the solar eclipse. And as we recall, after the COSMIC-2 operates, then there's 2 total eclipses occur. And one is in the 2017, and one is in 2014, this year. And both case, we can observe the depletion locations of the subpoint of the solar eclipse. And this is for only for the showing in the horizontal manner, but in different altitudes. So this is 200 kilometers, 300 and 400 kilometers. Then we can find the evolutions and displacements of the different locations of this effect of the depletion. And then if we go to the horizontal, vertical manners, that this is altitude and this is latitude. So it's basically the longitudinal cut. Then at the initiate of the solar eclipse, we can find in the southern hemisphere, here's a depletion here. And then after the depletion in the northern hemisphere here, we can both also find there's depletion locations, and they are very correlate to the locations of the shade of the moon. Also, this is my summary that we have the now operating the day-to-day visibility and observations to the ionosphere, and the data and products are capable to be downloaded. And we already observed 3 storms, 3 minor storms, and they are showing particular results. And it can be used to observe some interactions between the solar systems and solar radiations, and even the coupling from the below. So currently, we are making the near real-time GIS, and we try to make it 1 hour time resolution, and it will take like 2 hours data, 2 hours latencies when we have the 20 minutes resolutions. So we are also trying to extend the range of these models that data simulations to the Ionosphere. So we are now developing such kind of models. And this is just the validations that we compare with the ground-based Ionosphere. And also to compare, we also compare or validate with the network that the sea lions from NICT, they have a lot of Ionospheres in the Southeast Asia. So we can see that in the NNF2, the correlation is quite good. But in the HNF2, of course, because of the deviation of the radio occultations, that is decreasing of the correlation, but still above 0.5. Yeah. Thank you very much. That's my talk, and I'm willing to take questions.
Thank you. Any questions from the audience?
When you were maybe a slide or two slides before where you were talking about making the real-time data, the GIS data, the 2-hour latency, can you explain how did you come up with that 2-hour latency number? Was there a reason for the 2-hour rather than say 3-hour or 1 hour?
So responsible to answer that, I'm not quite precisely, but I will take the question back to Charles. Yeah, thank you very much.
Any other questions? Not, let's thank our speaker again. Thank you.
Thank you very much.
Our next speaker is Nick Peditella from UCAR.